X movement and automatically turns on, providing added security and convenience. Plus, with its solar-powered design, there's no need for wiring. Just set it up and let the sun do the work. I'll be testing this light in a detailed video soon, so stay tuned for that. But if you're interested in getting one right now, click the products button here to check it out. Make sure to like, share, and subscribe for more cool gadget showcases. Today I've built a powerful mini DC fan using a high-speed DC motor typically found in drones and a supercapacitor as the power source. Drone motors are known for their impressive speed and efficiency, making this fan surprisingly strong for its size. The supercapacitor I've used can store and release energy much faster than a regular battery, which gives the fan a quick and powerful start. Now let's test it out. This is an LED. Now let's connect it to a 3.7-volt battery through a 100-ohm resistor. As we complete the circuit, the LED lights up, indicating that the current is flowing in the correct direction. Now let's reverse the polarity by swapping the battery connections. Since LEDs are diodes, they block current when reverse biased, so the LED does not light up. To solve this issue and allow the LED to work regardless of polarity, we'll use a bridge rectifier. Now we reconnect the battery and the LED lights up, which is equal to 500 million microfarad, which is a very big value. For complete details, visit sciencequizbook.com. Today I have used 4 1N4007 diodes to build a full-wave bridge rectifier, not for AC to DC conversion, but to change polarity. Let's test it. I connected a DC power source with the rectifier and swapped the input polarity. Normally, reversing the polarity could damage sensitive components, but with this circuit, the output polarity remains the same no matter how I connect the input. This technique is super useful for protecting circuits from reverse polarity connections. What should I test next? Let me know in the comments. And don't forget to like, share, and subscribe for more cool experiments. Hey friends, today I've built a cool little gadget, a supercapacitor-powered mini-hand fan. I call it the Turbo Breeze fan. This tiny fan runs without a traditional battery. I've used a simple setup, a DC motor, a supercapacitor, and a switch. Now let's charge the supercapacitor with a 3.7-volt battery for a few seconds. Okay, here we go. I'm flipping the switch, and look at that, it's spinning effortlessly. But here's the twist. How can a fan run with just a few seconds of charging? What's the secret behind the supercapacitor's power? Can you guess the science behind it? Let me know in the comments. This is a 12-volt LED. Let's try to light it up using a 3.7-volt battery. But wait, it's not working. As expected, the voltage is too low. Now let's try something different. I've connected 2 DC motors using pulleys and a rubber band, so when one spins, it drives the other. Let's see what happens next. Watch carefully. I'm going to connect the same 12-volt LED to the terminals of one DC motor, and now I'll connect the 3.7-volt battery to the other DC motor. Still nothing. But what if we switch the polarity? Look at that. The LED is glowing. But how? Just a moment ago, the same battery couldn't light it up. Now with this setup, it works perfectly. What just happened? Can you figure it out? Let me know your thoughts in the comments. This is a DC gear motor. When I connect it to a battery, it rotates in the clockwise direction. If I swap the positive and negative wires, the motor reverses its direction and rotates counterclockwise. This happens because a DC motor's rotation depends on the polarity of the power supply. However, in some applications, we may need the motor to always rotate in the same direction, regardless of how the power connections are made. To achieve this, we can use a bridge rectifier. A bridge rectifier ensures that the polarity reaching the motor remains consistent, even if we change the input connections. Now, I have connected a bridge rectifier to this motor. As you can see, even when I swap the battery terminals, the motor continues to rotate in the same clockwise direction. This setup is useful in circuits where maintaining a fixed direction of rotation is crucial. This is a mini DC gear motor, and today I'm going to experiment with it to see how much electricity it can generate when I manually spin its shaft. First, I'll attach this chunk to the shaft to get a better grip for spinning. Next, I'll connect the positive and negative probes of my multimeter to the motor's terminals. Now let's spin it and see the results. As you can see, the motor is generating electricity, but the voltage is showing as negative because I connected the wires in reverse. Let's correct that. Now, with the correct polarity, you can clearly see the voltage output from this DC gear motor. If you found this experiment interesting, don't forget to like this video. Also, comment below with the voltage reading you see and share your thoughts on this experiment. Let's discuss. This right here is one of the most powerful supercapacitors you'll come across. It's rated at 2.7 volts and an incredible 500 farads. Yes, 500F. But what does that really mean? To give you an idea, a 500F supercapacitor can store a surprisingly large